In this video, I'm going to cover 3.4a, Introduction to Transformations. So we're going to learn transformations with quadratic and absolute value functions. So the first thing I'm going to do is I'm going to reintroduce you to the parent function. So first, let's go over the quadratic function. So f of x equals x squared. That's our function rule for our parent function. So remember also, f of x equals a times x minus h squared plus k is our vertex rule. Our h, remember you're going to use the opposite sign. And k, you're going to use the same sign. So what is our h and our k here in this function rule? Well, both h and k are 0 because you don't see them there. They're not illustrated in this parent function. So if you don't see them, they are going to be 0. So, great. Let's do, here's our vertex at 0, 0. So our vertex is 0, 0. Let's do some critical points. So 0, 0. Above it, we're going to have -1, -2. Below it, we're going to have 1 and 2. So what would happen if I started replacing these values? So let's put -1 squared would give me 1, -2 squared would give me 4, 2 squared would give me 4, and 1 squared would give me 1. And then we can go and graph them. So I know that both -1 and 1 are at 1. So right here. And I know that -2 and 2 are at 4. So here and here. And then I can go ahead and draw my graph. Just like that. I want to make sure it looks like a U. Okay? All right, so there's my parent function. Again, with the absolute value, here is my parent function rule. And again, my vertex form, where we're going to use the opposite sign on the h and the same sign on the k. All right, so what is my vertex? Again, it's going to be h equals 0 and k equals 0. Okay, and so I know above it, I'm going to have -1, -2, and below it, I'm going to have 1, 2. So what's the absolute value of -1? It's 1. Absolute value of -2? 2. So this is me putting in my value into my function rule and figuring out my coordinate points. Absolute value of 2 is 2. Absolute value of 1 is 1. So wonderful. So start with your vertex, 0, 0. And then at -1 and 1, they're both at 1. And at -2 and +2, they're both at 2. All right, great. Then what I can do is carefully draw my function, making sure it looks like a V. Wonderful. Okay. So what happens, though? What happens to these parent functions with an X, with an H, sorry, and a K? And an A. What happens? And that's what transformations is about. So what can we do to these parent functions to change where they are in the coordinate plane? And what causes that change? So let's look at that. So transformation 1 is when you have added a K. Okay? So what does the K do? Well, if you have a positive K, then it's going to move the units up. Okay? So it's going to be X, and then your Y, you're going to add your K to it, because you're going up, which would mean you're changing the Y value, because the Y goes up and down. So if you have a negative K, then you're going to move down. So you're going to still be at the same place on X, but your Y, you're going to subtract your K from it. So it's going to go down. How about the H? Okay. Well, when h is positive, the graph moves to the right. And this time, you're going to be adding h to the x, because the x is what moves left to right. Okay? Okay? And if it's negative, you're going to move to the left. Okay? Again, you're going to be subtracting from the x, because that's what moves the function left to right. Okay. But remember, when you're looking at your function in vertex form, f x minus h, that's what's positive. So when you say minus h, when you pull it out, it's plus h, isn't it? So when you see it in your vertex form, minus h is what's going to move it to the right. And when you see it in vertex form plus h, that's what's going to move it to the left. So when you're looking at movement of the h, when you're looking at this transformation number 2 with the h, you got to think of it opposite in your mind. All right. So how about A? A does two things. A does a couple different things. One is when A, and I've already talked about this, if A is positive, then the graph, then your function, your f of x, keeps its orientation. Okay? But when A is negative, then f of x, then f of x reflects over the x-axis. In other words, it flips. Okay? It flips in the direction of the x-axis. All right. So also, when A is bigger than 1, when A is bigger than 1, when A is greater than 1, it narrows, which is a stretch, which is called a stretch. This means it narrows and gets closer to the x-axis, the y-axis. Okay? And when A is less than 1, it's called a compression. Okay? So A is less than 1, but A is greater than 0. Okay? When A is less than 1, greater than 0. It's called a compression, and it means that it widens. It widens and it gets closer to the x-axis. So what does this all mean? What would you do with all this information? Okay. Well, let's do some practice. So first, we're going to be able to describe it. Okay. First, you're going to describe it using the parent function, and then you're going to describe what changes have happened to the parent function. So here we have a quadratic, don't we? So the parent function of a quadratic is f of x equals x squared. Okay? But we've made some changes to the parent function. We've made a change here, and we've made a change here. We have an H and we have a K. So we're going to describe those changes. So what does the H do? Well, it's a -3, so we have to think of it as the opposite, as a plus 3, because when we pull it out, it's a plus 3, right? When we take it out of this vertex form. So we know that it's going to move to the right. So we shifted right. Three units. Oh, darn it. 3 units, okay? What else are we doing? Well, we also have a -3, which is a K. Means we also shifted down 3 units. Okay? All right, let's try another one. Again, it's another quadratic. So I'm going to start with the parent function. Okay? And here I have a change here, a change here, 2 changes there, and another change here. Okay, so what are all the things happening? Start with H, then do K. Actually, let's start with A. We'll start with A, and then we'll do H, and then we'll do K. All right, so A, first of all, it's negative. So I know that it's reflected Come on, please write for me. Reflected over x-axis. Okay? Then it's multiplied by 2, which is greater than 1. So I know it's stretched vertically by factor of 2. I can stretch this out a little bit. Okay. So now I've handled my A because it was negative and it was the 2. Wonderful. What's next? Well, let's do our H. Well, it's -3, so we have to think of that as +3. So I know that I shifted right. Come on, please write. Shifted right 3 units. Okay? And lastly, I added 2, so I know I shifted up . Let's see if my other Apple Pen will work better. Shifted up 2 units. Okay? Those are all the changes that happen to the parent function. So I'm going to leave this last one for now. For here, number 3. Now they're giving me all the changes. And I have to be able to take this parent function and add the changes to it. Okay. First it says reflected over the x-axis. Okay. Well, I know that's a change to A, but it's not talking about a compression or a stretch. Okay, so it just means that my x is going to be negative. Wonderful, because it reflected. Then it shifted to the left 3 units. Well, the left would be negative, but remember, in my vertex form, I have to change the sign. Then I'm going to put my x squared. Wonderful. And then I shifted up 3 units. All right. Let's do some absolute values. All right, great. So I know I see a change here, I see a change here, and I see a change here. Okay, great. So start with your parent function. So f of x equals x, the absolute value of x, right? Now let's start some changes. Let's start with A. So first of all, I know it's reflected over the x-axis. All right. I don't have a number there though, right? It's not greater than 1 and it's not less than 1. It's just 1, so I don't change anything. I don't have to write anything about a compression or a stretch. Okay, great. Then I know that here, my H, it's a -1, which I have to think of as +1. So I know it's shifted to the right. 1 unit. Okay. And lastly, I have my K here. So I know it's shifted up 1 unit. Just like that. All right, great. Let's do the next one. So again, it's an absolute value function. So I'm going to start by writing my parent function. F of x equals absolute value of x. What changes have been made? Well, I don't have an A term here, and I don't have a negative. So I don't have a compression, stretch, or a reflection. So wonderful. It looks like I just have to worry about my H and my K. All right, great. So right now it's a +1. So now I need to remember I have to think of it as a -1. So it's shifted left toward the negative direction 1 unit. And it also shifted down my K 4 units. All right, wonderful. Now I have the transformations and I need to write it in vertex form. So start with your f of x and you're going to take your parent function of the absolute value of x and make the changes. Well, I shifted right 2 units and I shifted down 3 units. So I know I don't have an A. So if I shifted right 2 units, I'm going towards the positive, I have to write it as negative. And then I shifted down 3 units, I write it -3. There's my function. Okay, so if you have any questions, please come and ask me, but try your practice assignment.